Friends, welcome to the next session of work energy power. So we started a new topic in this, that is collisions. Yesterday we gave two different types of collisions, one dimensional and elastic collision and inelastic collision. In that inelastic collision, two types of will be there. One is one dimensional, two dimensional. So one dimensional elastic collision, first we are going to discuss. What is one dimensional elastic collision means? So before collision, after collision, both the objects are moving in a particular single direction, only in one direction. That may be either along x-axis or along y-axis, isn't it? Either along x-axis or y-axis. So only in one particular direction before collision, after collision, two objects will be moving. So in the elastic collision means one dimensional elastic collision. So elastic collision means, yesterday we discussed. So what we said elastic collision? The collision in which both momentum and kinetic energy conserved. So law of conservation of energy you came to know. Conserved means momentum is constant, then momentum is conserved. Energy is constant, then energy is conserved. Okay. So first we are discussing one dimensional one dimensional elastic collision. For this, two objects we have to take, because for the collision to happen, minimum we require two objects. To happen collision, so we require minimum two objects. Therefore, we are taking two objects. Both the objects will move in one direction, one particular direction. So I am taking one object of mass m1, another object of mass m2. So both the objects are moving with some velocities. This object is moving with velocity, initial velocity u1. This object is moving with initial velocity u2. So both are moving. So both are moving means, to get collision, what is the condition? What is the condition means, let us assume if you have taken u2 greater than u1. u2 greater than u1 means second object is moving with more velocity compared to first object. If second object is moving with more velocity means first this object will go. So back side this object will be there. Then will the collision happen? So it will not happen. Why? Because so first it is going initially, it is coming with less velocity compared to u2. Compared to second object, this is moving with less velocity. Therefore, it will not go and hit this object. It will not get collision with this object. To get collision, second object means backside object should have more velocity. That is nothing but u1 should be greater than u2. If u1 is equal to u2, then collision will happen. So it will not happen collision at that time also. Why? Because if u1 is equal to u2, whenever you saw, separation between these two objects will be like this one. Separation will be same, means distance between these two objects will remain same, because both are moving with same velocity. So u1 is equal to u2 is not possible, u2 greater than u1 not possible. Only possible to get collision is u1 is greater than u2. And during collision, so m1, m2. So during collision, so this is first object, this is second object. First one is going to impart some force on second one, like that. Second one is going to impart some force on first one. Both are going to. So if I am doing like this hand is applying some force on this hand is applying some force on this. Therefore, so interaction is going to happen. So again, this is during collision. This is before collision. Now collision happened. After collision, so after collision, masses of the objects will not be changed. Masses will be same only. Then what is going to be changed means its velocities will be changed. So V1, V2 are the velocities after collision. U1, U2 are the velocities before the collision. So before the collision, both are coming near to get collision because U1 is greater than U2. After collision, so both are going to moving away, isn't it? So before collision, after collision, objects are moving in one particular direction. Therefore, this collision we are saying one-dimensional collision. And in this, we are taking elastic. Elastic means what is conserved? We said both momentum and kinetic energy. So now we are going to find in one-dimensional elastic collision, there are the equation for final velocities of the two objects after the collision they will answer. Okay. So final velocity means you should find V1 and V2. For competitive, also it is important. Directly you have to remember the formulas. So derivation will be a little bit bigger, it will be coming, but logically if you follow, it will be very easy derivation. Okay, the equations will be more, but concept will be a very simple concept you have to apply. So this is about one-dimensional elastic collision. So in elastic collision, what is conserved? We said both momentum and kinetic energy. So first we are taking according to law of conservation of momentum. According to law of conservation of momentum, so total momentum is constant. Total momentum is constant means before collision, after collision, momentum is same. So according to law of conservation of momentum, P is constant. What is P here? Momentum. Momentum means what is the formula? Product of mass and velocity is constant. So now we are writing this statement. According to law of conservation of momentum, momentum is constant means momentum before collision should be equal to momentum after collision. If one object is there means simply we will write it. But here two objects are there. Therefore, total momentum of two bodies before collision should be equal to total momentum of those two bodies after collision. So momentum formula how we will write, we will see now. So according to law of conservation of momentum, in exam you don't need to write this one. Directly you can write this type. So according to law of conservation of momentum, so total momentum. So total you use, therefore you don't need to use two objects. Total means how many objects are there? Total objects momentum. Total momentum before collision is equal to total momentum after collision. Now see, before collision what is the momentum we say? Before collision this one. So product of mass and velocity m1 u1. So this object momentum is m1 u1. This object momentum is m2 u2. Therefore total momentum how much? m1 u1 plus m2 u2. Correct? m1 u1 plus m2 u2. This is before collision. Now after collision. So m1 v1 plus m2 v2. So after collision what is the momentum? So m1 v1 plus m2 v2. So this is the equation according to law of conservation of momentum. Why we have taken momentum means because it is elastic collision. In elastic collision, what is conserved? Both momentum, and next we are going to take energy. So before going to take energy, see this equation. So separate m1 terms, separate m2 terms. So if you bring this one this side, m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Take on m1 u1 minus v1 m2 v2 minus u2. So call it as equation number 1. In this not 3 steps, only 1 step. That is according to law of conservation of momentum. Total momentum before collision, total momentum after collision. Later we have taken common means separated m1 terms, m2 terms, and we have taken common m1. Understood? Next. So momentum conserved over. Now according to so law of conservation of kinetic energy, because kinetic energy only will be conserved in elastic collision. In elastic collision, not inelastic collision. Okay. So kinetic energy conserved means what is constant now? Kinetic energy constant. What is kinetic energy formula? Of mv square equal to constant. Just keep it in your mind. That one you don't need to write. This one you don't need to write. So directly, law of conservation of kinetic energy means total kinetic energy before collision is equal to total kinetic energy after collision. Total kinetic energy before collision is equal to total kinetic energy after collision. Now see. So this is before collision, what is the kinetic energy? After collision, what is the kinetic energy? Total kinetic energy we have to write. In this there is no potential energy because object is moving. Therefore it is having only kinetic energy. So first one of m1 u1 square. This object kinetic energy. This object kinetic energy plus of m2 u2 square is equal to plus of m1 v1 square plus m2 v2 square. So half will be common both sides. Therefore remove half. Then what will be remaining? m1 v1 square plus m2 u2 square. m1 v1 square plus m2 v2 square. Again separate m1 numbers. m1 v1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Take common m1 is u1 square minus v1 square is equal to v2 square minus u2 square. Call it as equation number 2. So now equation number 1, 2 you got. Now after getting 1 and 2, 1 you got by taking momentum, 2 you got by taking law of conservation of kinetic energy. Till now 2 steps over. One is by taking conservation of momentum, one is by taking conservation of kinetic energy. But in your book you may get half page or full page, but only 2 steps over till now. Now next this one, after this you should remember this. Equation 2 Equation 2 by equation 1 means, see, equation 2 LHS. What is there? m1 u1 square minus v1 square. And equation 1 LHS. What is there? m1 u1 minus v1. So this divided by this you can take. That is nothing but m1 u1 square minus v1 square by m1 u1 minus v1. Next m2 v2 square minus u2 square by m2 v2 minus u2. So both will be cancelled. Then this is a square minus b square. How we will write a square minus b square? A plus b into a minus b. Similarly u1 plus b1 into u1 minus v1 by u1 minus v1 is equal to v2 plus u2 v2 minus u2 by v2 minus u2. Since a plus b into a minus b equal to a square minus b square. That is formula already you came to know in mathematics. Now see here, these two will be cancelled. And what will be remaining? u1 plus v1 is equal to v2 plus u2. Separate u1 terms. u1 minus u2 is equal to v2 minus v1. Call it as equation number 3. So see that equation clearly. So u1 minus u2. So already you came to know what is u1 minus u2. Relative velocity. Did you remember? Relative velocity of two objects u1 2. is equal to u1 minus u2. Already we discussed VAB equal to VA minus VB. Relative velocity of two objects. Same like that. V2 minus V1 also relative velocity. But this is relative velocity when before collision. So this relative velocity after collision. So before collision both are getting closer. That is nothing but approach. So relative velocity of approach when before collision. So now this one separation. These are separated. So relative velocity of separation after collision. Therefore, equation 3 is saying relative velocity of approach before collision is equal to relative velocity of separation after collision. So relative velocity of approach before collision is equal to relative velocity of separation after collision. So till here they may ask for 3 marks question. So in 3 marks question sometimes they will ask, how they will ask, show that relative velocity of approach is equal to relative velocity of separation during one-dimensional elastic collision or during one-dimensional head-on collision. Head-on collision means both are going to collide each other, either head-on collision or one-dimensional elastic collision they will ask. So how they will ask question? Show that relative velocity of approach before collision is equal to relative velocity of separation after collision. At that time you should derive up to here. But now in this class we are deriving final velocity. So 5 marks question they will ask. Derive the final velocities during one-dimensional elastic collision they will ask. So final velocities means here V1 and V2 we should find. How we will find V1 and V2 means, again from here we have to continue. How we will continue means here. From the equation number 3. So we can write from 3 V2 is equal. This minus V1 will bring this side. V1 plus U1 minus U2. Correct only? So U1 minus U2 plus V1. If we substitute this V2 in equation number 1 or equation number 2, then we will get, which one we will get? If we substitute V2 here, we will get V1. If we substitute V1 here, we will get V2. Therefore, first we are substituting V2. From equation 3, we wrote V2. So we are substituting this V2 in equation number 1. Substitute V2 in equation 1. So you can substitute in the equation number 2 also, but it is going to be a little bit difficult. Why it will be difficult means here square is there. So V1 plus U1 minus U2 square is should be. So doing square is little bit difficult. Therefore, we are substituting in this equation. So by substituting in equation number 1, how this equation is going to be changed? Now see, we are substituting V2 in equation 1. What is equation number 1? M1 into U1 minus V1 is equal to M2 into V2 minus U2. Correct only? So if this equation is wrong, we won't get correct answer. Correct only? M1 into U1 minus V1 is equal to M2 into V2 minus U2. This is equation number 1. Already it is there, but I erased here. So this is, in this V2 we have to substitute. So for that, M1 into U1 minus V1 is equal to M2 into V2 value, how much you got there? V1 plus U1 minus U2. V1 plus U1 minus U2. This is V2. Next, minus U2. Expand this. So M1 U1 minus M1 V1. So M2 V1 plus M2 U1 minus M2 U2 minus M2 minus M2 U2 minus M2 2 M2 U2. So M1 U1 minus m1 v1 is equal to m2 v1 plus m2 u1 minus 2m2 u2. We want v1, isn't it? So we want v1 means this minus v1, m1 v1 you can bring this side. These two you can bring this side. So this one right side, these two left side. Don't draw these diagrams on the notes. Just I am giving how it is going to be exchanged. So m1 u1, this one we are bringing left side, minus m2 u1 plus 2m2 u2 is equal to, so m1 v1 it is going to become plus, and again already is there, plus m2 v1. So in this, what is common you can see? In this u1 is common, m1 minus m2 plus 2m2 m1 plus 1. In this v1 is common. Now v1 is equal, you can check once. v1 is equal to this m1 plus m2 will be coming this side, m1 minus m2 but m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So this is the equation for v1, m1 minus m2 by m1 plus m2 u1 plus 2m2 by m1 plus m2 u2. So this is v1. Once again I am writing here because it may not be visible. u1 2m2 u2 by m1 plus m2. Call it as equation number 4. So we have derived up to here one question I said, but continuing this one is another 5 marks. Now we got v1. Now we should get v2. So to get v2, what we should do means again we have to take equation number 3. From this equation number 3, we have to write v1. If you wrote v2, you got v1. If you write here v1, you will get v2. Okay. So from equation number 3. From 3, v1 is equal. v1 is equal to v2 minus u1 plus u2. Correct only? This minus v1 I am bringing left side. This is going to become minus u1. This is going to become plus u2. v2 minus u1 plus u2. Now substitute v1 in equation 1. Again same. In equation 1 you have to substitute. What is equation number 1? m1 into u1 minus v1 is equal to m2 into v2 minus u2. So m1, so u1 minus v1 value how much? Minus is there, therefore carefully we have to write v2 minus u1 plus u2. Then keep bracket for v1 because this minus will be multiplied for all is equal to m2 v2 minus u2. So if class is going means actually you will only derive this one, but we are there, therefore I am deriving here. So m1 into u1, so minus v2 plus u1 minus u2 is equal to m2 v2 minus u2. So u1 plus u1, 2u1. So m1 2u1 minus v2 minus u2. So m2 v2 minus u2. Expand this. So 2m1 u1 minus m1, this is v2, minus m1 v2 minus m1 u2 is equal to m2 v2 minus m2 u2. So again send m1 v1 times v2 times. This minus m1 v2 will be going this side. This minus m2 u2 will be coming this side. Okay. So this minus m1 v2 will be going. Then it will become m1 v2 plus m2 v2. This is going that side. Next, this is going. This is minus m2 u2 is coming this side. 2m1 u1, 2m1 u1 plus m2 u2 plus m2 u2 minus m1 u2. Correct only? Then v2 is common. v2 is common means m1 plus m2. Here u2 is common. 2m1 u1 plus u2 is common means m2 minus m1. Correct only? Then b2 is equal 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. Call it as equation number 5. This is the final velocity after collision. See here, small difference will be there. Okay. So how to remember this one? Simply you can check once. V2 is coming means it is starting with 2. V2 2. M1 by M1 plus M1. V1 is U1 U2. Whenever this is V1, what you got here? M1 minus M2. Just how to remember I am saying. By M1 plus M2. 2. 2M2 by M1 plus M2. V2. You can take here U1. Here U2. So U1 means what you got here? It is starting with 2. Therefore, 2M1 by M1 plus M2. Here it is U2. Therefore, M2 minus M1 by M1 plus M2. Denominator M1 plus M1. How to remember logically, that is your wish. Okay, you don't need to remember as it is like this one. But finally, you should remember these two equations. Otherwise, it will become problem whenever we are solving the problems. Okay, competitive or PU, it is going to become difficult if you are not able to remember the formulas. Okay, this is V1. So V2 we got 2M1 U1 by M1 plus M2 plus M2 minus M1 by M1 plus M2 into U2. Some people will write this equation by taking minus common, M1 minus M2 they will get it. That one also same. So this is V1, V2. Final equations, final velocities after collision. So this derivation is important for 5 marks. In this, so many steps are not there. Up to here, 3 steps are there. So to get equation 4, this is 5th step. If you substitute V2 in this equation, this will be coming under mathematics again. Okay, this will not be coming under physics, because derivation we are going to just arrange minus and plus term. If you substitute V2, you will get V1. If you substitute V1, you will get V2. So these are the final equations after collision. Now we are going to discuss different cases in this. Next, different cases. Different cases means first object is moving, second object is at rest position. Then only collision will happen. First object is at rest, second object moving like this means collision will not happen. Okay. So during that time, so an object is moving and hitting another object which is at rest. Second object is at rest means that U2 is 0. At that time, in this equation we will put U2 as 0. And sometimes both object masses will be same. And sometimes U1 will be more. Sometimes U2 is more. U2 is more means collision will not happen. Okay. Sometimes mass of the second object is big. Mass of the first object is less. During different cases, how the collision is going to happen, we are going to see. Before going to see that one, again just we will get confusion by writing to remember these equations, because all the time we cannot derive entire derivation. Just logically we have to remember. Once again I am saying. So if you create by your own, you will remember very well. Otherwise, you can follow this one. Otherwise, not 2 to 3 times whenever we are walking or whenever we are free. We are writing V1. So take U1 here, U2 here. Keep one bracket here. We are writing V2. Again, U1 here plus U2 here. Keep one bracket. In this bracket, what will become? Whenever it is starting with U1, we are going with M1. Otherwise, V1 you can take M1. U1, M1. M1 minus M2 by denominator, everyone will remember. Next, U2. Whenever it is coming U2, we should get M2. 2, therefore here you will get 2. 2M2 U2, 2M2 U2 by M1 plus M1. So So this is the equation. Next, here u1. Whenever u1 is coming, what I said? u2 is coming, m2. u1 is coming, m1 will come. m1. This is second equation. v2. Therefore, take 2 here. Just how to remember, that is your wish. Then finally, denominator will be m1 plus m2. Again, here what is coming? u2. u2 came means what I said? m2. Therefore, here m2 minus m1 by m1 plus m2. Because very difficult to derive all the time equation. Just simple logic, if you use not only this one, in your own way, how you are able to remember these equations, that is important. Case 1. Case 1. Second object is at rest. Second object is at rest, but first object is moving. First object is moving with what velocity? m1 is moving with u1. So m2 is at rest, u2. Then what are the final velocities? Simple. So v1 is equal to u2, you can put 0. Then what is the equation? So m1 minus m2 by m1 plus m2 into u1. And v2 is equal to u2 is 0 means 2m1 u1 by m1 plus m2. So because second term will not be next. Case 2. If m1 mass is greater than u2, second object is at rest. First object mass is more means very big. Second object mass is less. So then this condition we are going more, bigger. Then what will happen? If this is going to hit this one, this is going to move with double the velocity, isn't it? If this object is coming and hitting this one, that is, the ball is hitting wall. Wall is bigger object than ball. Then ball will be coming with the same velocity backwards. Like that it will happen. So v1 we are going to get. So v1 we are going to get almost 2u1, almost. After collision, so second object is moving with more velocity, v2. So v2 is going to, so just you can substitute here. This mass is more. This mass is more means compared to this one, this value is going to become more. This will be m1 plus m2. Okay, just it is moving. Second object is moving with more velocity. Not first object. First object as usually it will move with u1. Second object is moving with 2u1 or 2. How much it is at rest. Therefore, how much velocity it will be having with the double velocity. Second object is moving. Just this is hypothetical theory issue. We can't show equation according to equation because so first object mass is more. So reverse means if m2 is moving and hitting this object, first object is at rest position, then u1 is 0. If first object is moving means with how much velocity it will be coming, with the same velocity second object will move. That is nothing but this object. That is case 3. If m1 is greater than m2, u1 is 0. u1 is 0 means this object is having initially 0 velocity. So 0 velocity means then second object is coming with what velocity? With the same velocity it will be moving. Then v2 is equal to minus u2. Why? Because opposite direction. So this example is ball is hitting the wall. Whenever ball is hitting the wall will be there only. Again ball will be coming backwards, isn't it? With how much velocity ball is moving, same velocity ball will be coming back. Here, with how much velocity it is hitting, this velocity is going to double in this case. In this case, reverse. With the same velocity it is going backwards. Okay, so these two are not that much important. This is very important. Case 4. Only this case 4 they will ask for 3 marks question. So what is this one means? If m1 is equal to m2, if both the masses are same, if both the masses are same, so what is their velocities? v1 is equal. Here both the objects are moving, or both the objects masses will be same. At the time, how the v1 is going to become? v1 is equal to, so m1 equal to m2, m1 equal to m2 equal to, you can take m minus m by m plus m u1 plus 2m1 m plus m u2, that is equal to m minus m is 0 plus 2m by 2m u2, then v1 equal to u2. Now this is small a, because already we will discuss case 1, case 2, case 3, case 4, 1, 2, 3, 4, 5 equations. Next, second equation. V2 is equal to, how much you get? 2m by m plus m minus m by m plus m u2. 2m by 2m. 0. And v2 is equal to u1. See the b. So by seeing a and b, so u2 is the velocity of second object before collision. v1 is the velocity of the first object. u1 is the velocity of the first object before collision. v2 is the velocity of the second object. Means velocity of first object is going for velocity of second object. Velocity of second object is going for velocity of the first object. Means they are exchanging their velocity. This one you can observe in billiards game. Billiards game, second ball is at rest position. Whenever one ball, because all the balls will be having same mass, one ball is hitting this ball, and which is hitting, that ball will come to rest. That which is at rest, that ball will be moving with same velocity, because both the balls are going to exchange their velocities. Same like that. Here two objects are going to exchange their velocity. Second object velocity is going for first object. First object velocity is coming for second object. Therefore, they are exchanging the velocities by observing E and B. This one only they will ask in 3 marks question. Show that if two objects of equal masses are getting one-dimensional elastic collision, they will exchange their velocities. At the time, you don't need to derive at v1, v2. So you can take v1, this equation and this equation, substitute. If m1 equal to m2 equal to m, you can write as it is like this. So you will get 3 marks. This is 3 marks question, very important question. Logically also you have to remember. Whenever collision happens between two equal masses, they are going to exchange their velocities. Okay, this is very important case for exam point of view. First is this one for problems. Last is this one. These two are not that much important. Okay, logically you can remember these two. So till now we discussed one-dimensional elastic collision. We have shown before collision, after collision. So relative velocity of approach equal to separation. And another 5 marks question, that is final velocities after collision, and different cases, case 1, 2, 3, 4. But fourth case is important for 3 marks question we said. Now we are going to discuss inelastic head-on collision or inelastic one-dimensional inelastic collision. So what is the definition of inelastic collision? Means the collision in which only momentum conserved but not kinetic energy. So that is called inelastic collision. So only momentum is coming, and which collision we are saying means after collision both are moving with the same velocity or common velocity. In inelastic collision, both the objects will move with same velocity after collision. Let us assume you are running for a running bus. Bus is running, you are running to catch the bus. So you are also running, bus is also moving. So after some time you capture the bus and you went into the bus, and now you and bus will be moving with same velocity after the collision. So that is also collision, isn't it? Like that. So you can take any other example. A cart bull is moving. You are catching that one. After catching, so your friend is moving on a bike. So you went onto the bike after some amount of time running. So after catching the bike, both are moving with same velocity. So that type of collision will be coming under inelastic collision. So a bullet is fired into the wooden block. So which is hanged. So which is hanged means it is at some place, bullet is coming and hitting. Then both bullet and the block will move some distance, isn't it? With some velocity. So that is nothing but common velocity they will say. How we will show a conductor diagram? So this is M1 with velocity U1, it is moving. This is M2 with velocity U2, it is moving. So after collision, M1 and M2. So both are moving with same velocity. That is nothing but. So V1 is equal to V2 is equal to V. So after collision, M1 and M2 will be having same amount of velocity. So first we will see according to equation. According to law of conservation of momentum. So momentum before collision equal to momentum after collision. That is nothing but M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So M1 U1 plus M2 U2 is equal to M1 plus M2. So both will be having same velocity, M1 V plus M2 V. So M1 U1 plus M2 U2 is equal to M1 plus M2 into V. Then V is equal to M1 U1 plus M2 U2 by M1 plus M2. This velocity we will call it as common velocity. Common velocity means both the objects will move with same velocity. So this collision we are calling it as inelastic collision. After collision, both the objects will move with common velocity. So in this we can't take kinetic energy, right? Because kinetic energy before collision, after collision will not be same. So will not be same means some amount of energy is going to be lost. The loss of kinetic energy. How much energy it is going to be lost? We are going to find. Okay. So in this, we are saying only conservation of momentum. We are not saying conservation of kinetic energy. Why? Because kinetic energy will not be same before collision, after collision. So whenever it is not same, some energy is going to be lost. For elastic collision, both initial and final kinetic energy will be same. Then initial minus final or final minus initial, you are going to get 0. But here it won't come like that. Therefore, energy is not conserved. Kinetic energy is not conserved, we are saying. So therefore, some amount of energy is going in the form of loss, losing it is. So that loss of kinetic energy. So loss of kinetic energy in case of inelastic collision. So very important for competitive and PU also. This concept also very important for competitive and PU. Means they won't give inelastic collision. So a bullet is fired and it is embedded with wooden block. Both the blocks are moving with how much velocity they lost. At that time you should get realized that. So they ask the concept of this one. So they won't give two objects got collided in inelastic collision. Then what is the final velocity? They won't ask like that. Okay, you should remember. So applying concept is very important, especially collision concept. So loss of kinetic energy during which collision? Inelastic collision. Because elastic collision you won't have any loss. It will be total mode energy, final before and after will be same. So to get loss of energy, we have to find initial kinetic energy minus final kinetic energy. Otherwise, final kinetic energy minus initial kinetic energy. So first, what is the initial kinetic energy of m1 u1 square plus of m2 u2 square. So this is initial kinetic energy. So before collision. Next, after collision, what is the kinetic energy? That is final kinetic energy. So after collision, both are moving combinedly. Both are moving combinedly means total mass how much? M1 plus M2. Therefore, of mass is M1 plus M2 of M v square. V means this common velocity v square. Then of M1 plus M2. What is V value we got? Common velocity here we got. V is equal to, so M1 U1 plus M2 U2 by M1 plus M2 whole square. So still if you want to expand this, 1 M1 plus M2 will be cancelled. Then what you will be getting? M1 U1 plus M2 U2 whole square by 2 M1 plus M2. So this square is there for this one and this one. One square will be cancelled here. Therefore, remaining is this. This is the final kinetic energy. This is the initial kinetic energy. If you want to get loss, delta K, that is nothing but Ka minus Kf, or Kf minus K also you can do. Somewhere you will get negative sign. No problem. However, you did of M1 U1 square plus of M2 U2 square minus this one M1 U1 plus M2 U2 whole square by 2 M1 plus M2. 2 M1 plus M2 is LCM. Isn't it? Otherwise you can take half common. Otherwise M1 plus M2 LCM you can take. If you have taken M1 plus M2 LCM of M1 U1 square into M1 plus M2 plus of M2 U2 square into M1 plus M2 minus M1 U1 plus M2 U2 is whole divided by M1 plus M2. Correct only? So for all these, what is there? Half is there. 1 by 2 is there. So you can take this 1 by 2, 1 by 2, this 1 by 2, M1 plus M2 outside. Common you can take. 1 by 2, M1 plus M2 you can take. Half is there for half of 1 by 2 is there. Isn't it? So this 1 by 2 and this M1 plus M2 we have taken LCM like this. You know how to take LCM. Okay, therefore this one and this two I wrote this here. Remaining you can write within that. So M1 into M1 square U1 square plus M2 into M1 M2 U1 square. Next M1 into M1 M2 U2 square plus M2 square U2 square. So these 4 terms, 1 into, this is 1, 2, 3, 4. Total 4 terms we got. 1, 2, 3, 4. Next, this one, A plus the whole square. This is minus, this half went for common. A plus whole square, M1 square, U1 square. Minus, I am expanding minus also. M2 square, U2 square. Minus 2M1, M2, U1, U2. Minus 2ab, because this minus is expansion, a square plus b square plus 2ab. This minus is going to expand for each and everything. Minus into this one, minus into this, minus into this. If you want to write another step and multiply with minus. Okay. So now see here, m1 u1 square, m1 square u1 square, these two will be cancelled. Like that, these two will be cancelled. Then what remains you can see? 1 by 2 m1 plus M2. Inside M1 M2 U1 square, M1 M2 U2 square. Here minus 2M1 U1, M2 U2. Isn't it? So m1 m2 m1 m2 m1 m2 you can take common. So m1 m2 by 2 into m1 plus m2 u1 square plus u2 square minus 2u1. Then what you will get? A square plus b square minus 2ab. Then a minus b whole square. A minus b whole square means half m1 m2 by m1 plus m2 u1 minus u2 whole square. So that is the loss of kinetic energy. Just I am writing formula here. So delta T is nothing but half m1 m2 by m1 plus m2 u1 minus u2 whole square. So very important equation for both PU and competitive purpose, and they will ask problems on this. So find the loss of kinetic energy in case of inelastic collision and common velocity. So they won't ask directly. By seeing the problem, you should understand that they have asked problems on these. So energy loss will be there only for inelastic collision. There is no loss of energy in case of perfectly elastic collision. Okay.